if z into x plus y equals x square plus y square, show that dou z by dou x minus dou z by dou y whole square equals 4 into 1 minus dou z by dou x minus dou z by dou y. So now we will prove that. We'll first prove LHS and then we'll prove RHS. So here they've given z into x plus y equals x square plus y square. So first we will prove this LHS. So to prove LHS, we'll first find dou z by dou x and then we'll find dou z by dou y. So let me find dou z by dou x into, we'll use product rule, first term differentiation, second term as it is. Then plus first term as it is and second term differentiation, partial differentiation. X will be 1, y will be 0, will be equal to x square will be 2x differentiation, then y square is 0. So it will become dou z by dou x plus y plus z equals 2x. Now dou z by dou x is 2x plus goes other side become minus z, multiplication goes other side become division. So we'll call this as equation. We'll call this as equation 1. We'll call this as equation 2. From equation 1 you can write z equals x square plus y square divided by x plus y. We'll just keep the x value. Sorry, z value. Now we'll differentiate with respect to y. We'll differentiate with respect to y. Z into x plus y equals x square plus y square. Now differentiate with respect to y. Partial differentiation. Dou z by dou y, second term as it is, plus difference first term as it is, differentiation of second term. That will be x will be 0 and y will be 1. We are differentiating with respect to y, partially differentiating. Then first term will be 0, second term will be 2y. So now dou z by dou y into x plus y plus z equals 2y. So now dou z by dou y equals 2y plus goes at the side become minus z divided by x plus y. So this will be equation 3. Now according to the LHS we have dou z by dou x minus dou y by dou x whole square. We'll substitute the values. So we have dou z by dou x is 2x minus z. It is 2x minus z, 2x minus z divided by x plus y. Then here minus of 2y minus z divided by x plus y whole square. So now since the denominator is same, we can write the numerator as it is. Same denominator. So 2x minus z minus 2y minus into minus, this is one term, minus into minus become plus z whole square. So that will be z and z will get cancelled. You get 2x minus 2y divided by x plus y whole square. So now this we can write it as, I'll take 2 common. Square of 2 will be 4. I'll take 4 outside. That will be x minus y divided by x plus y whole square. We'll call this as equation 4. That is your dou z by dou x. This is dou z by dou x minus this is dou z by dou y minus dou z by dou y whole square. We got the first LHS answer. So now let me take RHS. So to prove RHS, we'll go with to prove RHS, we will take now, we have 4 into RHS is 4 into 1 minus dou z by dou x minus dou z by dou y. Now substitute the value of dou z by dou x and dou z by dou y values. So now what we get? We get, yeah, 4 into 1 minus 2x 2x minus z divided by x plus y minus of 2y minus z divided by x plus y. Now 4 into, you take LCM, so common LCM x plus y. So if denominator is 1, we should directly multiply the LCM x plus y. Here it is in the bracket, so remove the bracket, minus 2yx minus into minus plus z. Even here it is in the bracket, so remove it. It is minus 2y minus into minus plus z. So now it is 4 into x minus 2x is minus x, y minus 2y is minus y, x plus z is plus 2z divided by x plus y. So now we get 4 2z minus x minus y divided by x plus y. So now we know that z value is x. We have z value here, we have already written x square plus y square divided by x plus y. So we'll just write that it is x square plus y square divided by x plus y minus x minus y. Now this x plus y, I'll take it outside, that I'll write it out, x plus y. Now it will be 4 divided by x plus y. Take the LCM now inside. It will be 2 into x will be 2x square plus 2 into y is 2y square. Then it is minus, this I'll take it in a bracket, that will become minus, if I take common it will become minus x plus y. So now multiplying the denominator with this numerator, it will become minus x plus y whole square divided by x plus y. So now we'll take x plus y as common denominator, certainly x plus y whole square, then into 2x square plus 2y square plus formula, we'll take formula minus of x square minus of y square minus of 2xy. We are just using the formula, identity formula, that is 4 into x plus y whole square into 2 minus 1 is x square plus y square. If you subtract, minus 2xy. So that is nothing but a formula. It is 4 divided by x plus y whole square into x minus y whole square. So that is your equation, that we can write it as 4 into x minus y divided by x plus y whole square. That is your, call it as equation 5, and we can see 4 and 5 are same, therefore LHS is equals to RHS, hence it is proof.